Welcome, everyone. Today, we're going to talk about a fundamental shift in computing, moving from silos to synapses. This is the blueprint for AgentOS. In this presentation, we will explore why the future of computing requires a clean slate architectural redesign, one that is driven not by isolated applications, but by human intent. Let's set the stage. Recently, we've seen a massive eruption of local autonomous agents. Open-source systems have gained immense traction, accumulating over 100,000 GitHub stars within weeks. We are now dealing with continuously running agents, often described as having clawed with hands, that execute direct operating system-level actions. Through an autonomous agentic loop, they operate in the background and maintain long-term memory. Using protocols like the Model Context Protocol, or MCP, these agents integrate directly with our systems to read files, run terminal commands, and navigate our workspaces. But there is a major bottleneck we are currently facing, which we call the shadow AI crisis. Right now, these agents are forced to operate as user space processes on legacy operating systems. Because of this, they rely on brittle screen-as interface workarounds. Where a human perceives rich semantic context like folders and data, the agent only sees an opaque pixel matrix. This visual scraping fundamentally limits reliability. This brings us to a bold conclusion: the graphical user interface, or GUI, is dead for autonomous agents. Forcing agents to use a GUI causes a failure cascade. First, there is a loss of semantic information, as GUIs obscure underlying structured data and metadata, causing the agent to make reasoning errors. Second, we get fragile execution paths. Relying on visual coordinates means agents fail catastrophically if an app simply updates its layout. Finally, it creates runaway security risks, because legacy application permissions simply cannot distinguish between a legitimate action and an indirect prompt injection. To solve this, we need an architectural reconstruction. Let's compare the legacy OS to the proposed AgentOS. At the human-computer interface layer, we replace the GUI and desktop window manager with a single natural language port. At the application layer, isolated third-party silos are replaced by user-defined skill modules. Core management shifts from process and memory scheduling to intent parsing and multi-agent coordination. And for interactions, traditional system calls are replaced by the Model Context Protocol. Visually, the new AgentOS stack looks like this. The traditional operating system kernel isn't completely gone, rather, it is pushed down into the invisible infrastructure layer alongside the hardware. Sitting above that is the newly designed Agent Kernel, which becomes the primary interface. On top of that, we have the single port and the various skill modules interacting directly with the user. Let's zoom in on that top layer, the single port. This represents the death of the traditional desktop. Instead of a cluttered screen of icons, the system rests in a persistent, minimalist standby mode, passively accepting multimodal signals like voice, text, and context. Visual interfaces aren't static anymore. They are generated on demand only when strictly necessary to resolve ambiguity. This means your cognitive overhead is functionally eliminated. Beneath the single port sits the agent kernel. Its job has shifted from traditional process scheduling to intent orchestration. At its northbound interface, it translates ambiguous voice or text inputs into structured intent. At its southbound interface, it dispatches these structured directives to the file system, network, and hardware via the Model Context Protocol. Importantly, it also multiplexes your limited LLM resources across concurrent agent threads to prevent out-of-memory failures. This architecture marks the end of traditional applications. Functionality is no longer installed, it is dynamically composed. Think of it as skills as modules. The agent kernel takes your natural language requests and converts them into persistent, reusable microservices. Instead of opening a closed third-party app, the system synthesizes bespoke workflow logic, like extracting invoice data, verifying a budget, and drafting a payment, all seamlessly connected. But here is the most critical takeaway: AgentOS is not just a software architecture, it is a real-time knowledge discovery and data mining engine. Traditional operating systems are deterministic, but AgentOS is inherently probabilistic. Because natural language is always slightly ambiguous, the OS must act as a continuous data mining pipeline just to function correctly. How does it resolve this ambiguity? Through intent mining and the personal knowledge graph. The system continuously ingests voice logs, geolocation data, event logs, and text corpuses to build a personal knowledge graph. So, if you give an ambiguous command like book my usual flight for that conference, the system uses retrieval-augmented generation to infer your implicit preferences from your historical behavior in the graph, and resolves the command perfectly. It also optimizes itself over time using the KDD flywheel. Unlike a static OS, AgentOS observes its own execution. It monitors your action traces, uses sequential pattern mining to discover repetitive workflow loops, retrieves the right skills using a two-tower recommender system, and then dynamically synthesizes optimized background macros. It essentially replaces multi-step, high-latency interactions with fast, automated execution. Of course, delegating system control to probabilistic agents requires intense security. We govern this with a semantic firewall. Legacy access control lists just grant access based on app permissions, but AgentOS evaluates the semantic intent of every single request. If an indirect prompt injection tries to exfiltrate SSH keys, the firewall detects the tainted data and blocks it. And if an agent simply hallucinates and makes a mistake, the system uses virtualization to allow an instant state rollback to reverse the error. If the architecture changes, the way we measure success must also change. We are moving away from legacy metrics like system stability, CPU load, and crash logs. In the AgentOS era, our primary evaluation dimensions are user intent fulfillment and cognitive alignment. We will measure success through intent alignment, tool accuracy, hallucination rates, and context drift, utilizing new methods like tri-agent evaluation and agentic benchmarks. To conclude, this is the inevitable future of computing. We are moving away from the past of static logic, rigid structures, and manual processes. We are currently navigating the crisis of shadow AI, characterized by fragmented workarounds. But the destination is clear: probabilistic orchestration. Forcing AI to click buttons is just a transitional hack. The operating system of the future is a unified intelligent hub, a continuous data mining ecosystem designed to seamlessly translate human ambiguity into perfect, machine-driven execution. Thank you.